Good Wednesday morning. Good morning, Tara. Good morning, Chris, Andy, Molly, Jamie. Hope you guys are doing okay. Anyone else who's watching or joined in, good morning to you guys as well. We'll get going here in about a minute or so. Give people a few minutes because some people are like in chemistry, so they have to switch over. So give them a minute or two to log on. Then we'll get going. Um, if you guys have any questions, go ahead and type those in. First of all, let me make sure you can give me a thumbs up if you can hear and see me now. If you can hear and see me, give me a thumbs up in the chat box just so I kind of know you can hear me and you can't see me. And then if you have any questions, type those into the chat box at this time. I'd appreciate it so much. As I said before, we get to 5.3 notes, we will look at questions over 5.2 homework. So let's go ahead and jump in that. Do any of you all have questions on 5.2 homework? Hey, good morning, Taylor. Taylor, we're just taking questions on any questions over homework on 5.2 homework. All right, since I am not seeing it's 3 minutes after start time, giving plenty of people time to jump in. I'm not seeing any questions come across, so I assume we're good. So let's move on to 5.3 notes, okay? Lesson 5.3 notes. I'm going to minimize myself a lot just so I'm not all up in the screen. Hope you guys are doing well today. Hope all is going good. Thank you so much for being here on this Wednesday at 12:45. So, hey, let's go ahead and get started in 5.3. So, all of this is about radicals. Okay, lesson 5.1 was all about radicals. Lesson 5.2 is all about radicals. So now we go to what the radical looks like on the graph. Okay. 5.1 was going from radical form to exponential form. 5.2 which is what we just did, was multiplying and dividing with radicals. Now we go to the graph of radicals. Okay. So just to recap what we've done thus far with graphs, functions of graphs, we have done x squared. It is a parabola. Okay. We have done x cubed, which looks like this. Okay. we have done the absolute value of x, which is a v. We have done 1 over x, which looks like that. Today, we go to 2 more, radical x, and we also go to the cube root of x. Keep in mind that this is x to the 1/2, and this is x to the 1/3. So those are the same thing, right? Because the index is 2, it's raised to the first power, so x to the 1/2, x to the 1/3. All right? So we've done these 4. Now we're going to move on to this and this. So that'll be 6 functions for the year that you know. And then once we go to chapter 6, next, it will probably be in May when we get to chapter 6. We'll do another function as well. Okay? So let's jump over here. Now, here's the key thing, guys, with graphing radical functions. Every function we did, every single one of these we have done, we started with an XY table. Okay? We start with an XY table. Now, someone tell me what x's should we be putting in here? Okay? Someone type that in the chat box. Like, what x's? Like, should I just put any x, any value of x? Like, can I put like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Or what should I actually kind of keep in mind? Can someone answer that question? No worries, Jacob. No worries, man. Just getting started in 5.3 notes. So Tara says -2, -1, 0, 1, and 2. Okay, yeah, and that's normally what we do. We kind of stay around the origin, okay? But this is a little bit different, okay? Because it is a square root, okay? So what's the square root of -2? Well, you can't have a negative on the inside. That would be an imaginary number, and there's no imaginary numbers on this, okay? So we would not want to go negative. No negative here. All right? So then let's start at 0. Well, what is the square root of 0? The square root of 0, what times itself will give you 0? Well, 0 will. So I got a point at 0, 0. Next point we go to is 1. What's the square root of 1? What times itself 2 times will give you 1? Well, 1. Square root of 1 is 1. So 1, 1. Now, if I put 2 in here, okay, I'm going to get the square root of 2. All right? Now, just to kind of show you with the calculator, the square root of 2 is 1.414213562. So that probably would not be the best number to put in x to see what the y is. So what would probably be the best? That's like 1.41421. So I don't think that's I just don't feel like that's the best to graph because it's a decimal. But who could tell me what would be the next best number to put the x into? What would be the next best number? Hey, good morning, Maria. Yeah, very good, Tara. 4. Okay. So if we put a 4 in, good, Chris, 4. So the square root of 4 is 2. So 4, 2. The next number we would put in is 9. Think about this. We just want perfect squares right here, guys. and 9 would be 3. I got to go off the graph a little bit for that, so that's fine. So this graph looks like this right here. Okay. Now, so that is the basic function of the square root of x. If I was to go to y equals, type in the square root of x, I get this graph right here, as you see, that we have. Okay? So, that is the square root of x. Notice, it's not negative, because if you put a negative x in there, it's going to be an imaginary number. Okay? Because no number multiplied by itself will give you a negative number. So, that is the reason there. Okay? And then from there, we can identify the domain and range. So, just an easy description would look like that right there. It's just a line going out. Then let's identify the domain and range. So my domain is all the possible x values, all right? So none of these are my possible x values. So I know my domain is not negative infinity to infinity because none of these right here work. But 0 works on the x-axis, so we'll say 0. But what we need to say here is we need to put a bracket on there. That means it is included. That means that 0 is a part of the domain. Now, if I was to put like a parenthesis there, that means not included. But in this case, 0 is included. It is a part of the domain. It is a part of the xy table. So therefore, it is from 0. And then where does it go to? All the way to infinity. Keep in mind that direction would be infinity. So that's my domain. Then my range is on the y-axis. What are the possible y coordinates from here? Well, none of these are going to be there. Okay? None of these coordinates will work on the y. So the first y that works is 0, and that is included. So we put a bracket 0 to, think about this going up here is infinity. This will just keep going up and up and up and up forever. So it will go all the way to infinity as well. Okay, so with the square root of x, guys, you need to know some things, all right? The square root of x. Now, let's review x squared real quick. If I was to graph x squared, I go right 1 and up 1. I go right 2 and up 4. I go right 3 and up 9. Now, this is very similar to that, okay? But it's a little bit different. So, I start, everything starts at the origin, right? 0, 0. So, here I actually go right 1 with the square root of x. I go right 1 and up 1. So, that's the same. But the next thing I do is I go right 4 and up 2. So, it's the opposite of this right here. So I go right 4 and up 2. And then right 9, it's the opposite of x squared, up 3. Okay, and that is the square root of x. So that's the pattern we will follow. Okay, that's the pattern we will follow. So this right here is really important for you to know, especially when we get down there to the bottom ones. Okay, so let's jump over here to number 2 now, the cube root of x. So let's go with the, hey, good morning, Andrew. Hey, good morning, Karen. So let's jump over here to the cube root of x. You guys can just like watch from here and then like go back and watch the beginning and you can kind of see it later. Okay, so the cube root of x is simply, we just want to make an xy table for it. X, y. Okay, so now with the cube root of x, we're looking for numbers that multiply, or we're looking for numbers that can be put in here, put into this x, that you can multiply a number 3 times and get that number. So 0 will work here, and it's 0, 0. If you put a 0 in, what will multiply times itself 3 times that will give you 0? Well, 0. If you put a 1 there, 0 and 1 are pretty common. If you put a 1 in, what will multiply times itself 3 times to give you 1? Well, 1. All right? Then from there, you'd have to ask yourself, what's the next biggest number? Okay? So what is there a number multiplied by itself that'll give you 2? No. 3? No. 4? No. 5, 6, 7, 8. 8 would be your next best number, okay? 8 would be your next best number, and what multiplies by itself 3 times that'll give you 8? Well, 2 times 2 is 4, then times another 2 is 8. So the cube root of 8 is equal to 2. Okay, the cube root of 8 is equal to 2. What times itself 3 times will give you 8, and that's 2. All right? Now, here is the thing about cube roots. Cube roots, you can have a negative in this. I don't remember if you all can recall this when we discussed cube roots, but it can. Okay, so Taylor, good question. So how is it 8? So Taylor, just like we have perfect squares, we have perfect cubes too. We did this at the beginning of the year as well, and here's the basic understanding of that. I'll kind of write this on this paper right here. So like we're dealing with the cube root of x. So the cube root of 1 is 1. Because this is saying what times itself 3 times will give me 1. Well, 1 times 1 times 1 is 1. Okay? But if I say the cube root of 2, what times itself will give me 2? Well, some decimal that we don't know. Okay? So that's some decimal, okay, that we don't know. What will multiply times itself 3 times to give me this? Well, some decimal. Again, I don't know of any number, and we've already used 1, okay? So these are just like 1 point something that will multiply by itself to give us that 3. The cube root of 4, nothing will multiply by itself to give you that. And you got to keep in mind the next whole number is 2, okay? The next whole number is 2, and I know that 2 times 2 is 4, but it's not 2 times 2 times 2 is not 4, okay? So the way you think about it is saying, what is 1 times 1 times 1, which is equal to 1 cubed? What is that equal to? That's equal to 1. Well, then what's 2 times 2 times 2, which is 2 cubed? What is that equal to? 2 times 2 is 4, times 2 is 8. Then go to the next one. 3 times 3 times 3 times 3, or 3, equals 2 cubed, or excuse me, 3 cubed, which is equal to 27. 3 times 3 is 9, times 3 is 27. So, just like we have squares and square roots, same way with cubes and cube roots. So the cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. Does that make a little bit more sense, Taylor? Okay, cool. Very good. So we're putting numbers in here that are perfect. Now, we could put 27 in here, and that would be 3, but we know we're not going to go to the right 27. The graph's way too big, or way too small for that. But as I was saying before the question about y is 8, 2, what I was saying was this. A cube root, let me come over here and write this down. A cube root can have a negative. So what times itself 3 times will give me negative 1? Well, negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is positive 1, and positive 1 times negative 1 is negative 1. So this right here is equal to negative 1. Same thing with 8, the next one in line, negative 8. Now, what will multiply by itself 3 times that will give me negative 8? Well, negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. Positive 4 times that last negative 2 would be negative 8. So that is equal to negative 2. Okay? So we can use some x's here that are negative. So let's say negative 1 and negative 8. And as we just discovered, the cube root of negative 1 is negative 1. And the cube root of negative 8 is negative 2. Okay? So then we can plot these. 0, 0, 1, 1, 8, 2. Negative 1, negative 1, negative 8, negative 2. And this goes out like this. This goes down like, oh, whoa, sorry, pen got away from me. This goes down like that. If I show you the cube root of x on a calculator, we get the same thing. All right? So I can come over here and kind of add to this right here. So this just kind of looks like a snake going horizontal. Now going back to this whole cube root thing. Remember here we would go right 1 and up 1. We'd go right 2 and up 8. So same thing here, but it's just opposite with the cube root. So we will go right 1 and up 1. But then we go right 8, it's opposite, and then up 2. And then we also go left 1 and down 1, and left 8 and down 2. So that will be our pattern for cube root of x. Let's look at the domain and range. So my domain, again, this is negative infinity, that's infinity. So this arrow goes forever this way, so that means the domain is going to be from negative infinity all the way to, that arrow goes forever, to positive infinity. The range, this is negative infinity way down here, this is positive infinity down here. Notice this is going down, so it's going to go down forever that way. So that's going to be negative infinity. And same thing there, that's going to be positive infinity. All right. Any questions on that? Type those into the chat box. If not, give me a thumbs up that you're kind of seeing this. It's kind of following along. You're kind of following along with it. Good, Adam. Good, Chris. Good, Andy. Good, Tara. Good, Jake. Okay, seeing no questions. Good, Vandy. Seeing no questions, let's move on. Okay? Good, Andrew. All right, so it says sketch the graph of each function. Okay, sketch the graph of each function. So we're just going to sketch these graphs, and we'll go ahead and name the domain and range because I think your homework. Yeah, on your homework. Ooh. I'll have to tell you about your homework, but on your homework you have to do the domain and range for all of them. So I'll kind of we'll just do the domain and range for all these. All right. So look at number 3. It says y equals the square root of x minus 3 plus 4. So let's go back in time to chapter 1. Okay, we're on chapter 5 now. We've gone through a lot this year. I hope you guys have learned a lot this year. But going back to chapter 1. When we're dealing with functions and how they operate. What does this plus 4 on the outside mean to do, guys? What is plus 4 on the outside? Is that a horizontal translation, a vertical translation, up, down, or horizontal left or right? What does plus 4 on the outside mean? Anybody remember that? Okay. Maybe no one? All right. So remember that outside, when something's on the outside, if it's it's outside is going to be a vertical translation. Yeah, there you go, Taylor. A vertical translation. So if it's positive, you go up. If it's negative, you go down. You may want to write that little note down to help you there. So with a positive 4, that means we go up 4. All right? And then who remembers what the inside does? If it's on the inside, like with the square root or inside the parentheses, what does an inside do? Which is what we call, it's actually a horizontal translation. And now remember, this is opposite. If it is negative, you go to the right. If it's positive, you go to the left. So those are opposite than normal. Okay? All right, so as Taylor said, this plus 4 on the outside is going to push us up 4. Okay? So, now, keep in mind, if you don't know, if you were for some reason to forget this whole inside-outside rule, you can always just plug x's in there, make an xy table, and just plug them in and get the graph and then graph it. Okay, but knowing this knowledge and knowing the general shape of the graph helps. Okay, so plus 4 goes up 4, 1, 2, 3, 4. And then minus 3 on the inside goes to the right 3. It's opposite. When it's minus, it goes to the right. So up 4, 1, 2, 3, 4, and right 3, 1, 2, 3. So that's kind of now our new origin. And if you remember, I would always mark those two things off. Morning, Kinsey. So now we kind of have this function, y equals radical x. And what do we do with that function? Well, it's right here. Radical x function, we go right 1 up 1, right 4 up 2, right 9 up 3. Okay? So right 1 up 1. Then the next one is right 4. 1, 2, 3, 4 up 2. And I can't really go right 9 and up 3. It'd be way off the graph. So this graph just looks like this right here. If I was to type it into a calculator and graph it, that's it. Let me change the window here. I did those wrong. -8 and 8 max. This is the same graph as our piece of paper. So kind of see how that's going there. All right. So pretty simple. Just know those outside-inside rules of functions, and then just graph what we just figured out using these, using your shape of your graph. We did the same thing with x squared. Okay, did the same thing. All right, jumping over here, or let's identify the domain and range of this. So the domain is all the possible x values. So my possible x values here are from 3 all the way to, we know that's infinity. So from 3, and 3 is included, all the way to infinity. Sorry, conversation with my son. And then range would be from here, which is 4, and 4 is part of it, so we put a bracket, and it goes from 4 all the way to infinities up here. So this line is just going to keep going up, 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 all the way to infinity on the y-axis. All right, look at number 4. Y equals the cube root of x plus 3 minus 3. So minus 3 is a vertical translation down, and plus 3 goes to the left on the inside. So outside, this is on the outside. It's negative, so it goes down 3. Inside, that's plus, so that goes to the left. So down 3, 1, 2, 3. All right, Taylor. So I assume we're talking about number 3. Okay. So as I said, Taylor, before we did the same thing with like x squared. When we would have like, just an example, when we would have like x squared plus 2. All right. The normal graph of x squared looks like this. But when we had x squared plus 2, that was a vertical translation up 2. So we'd do our point there, and then we would still do our normal routine. Right 1 up 1, left 1 up 1. Right 2 up 4, left 2 up 4. And we would make our graph then. Okay? Then when we would have like x minus 2 squared, that's an inside. So that would be to the right 2. So go 1, 2, put our point, and then we would kind of mark that off, and then it's just x squared from there. Right 1 up 1, right 2 up 4, left 2 up 4. And we would graph. We're doing the same thing here. Okay? It's the square root of x minus 3 plus 4. All right? So that's why I started with these notes. Plus 4 is on the outside. So that means that this graph, this function, is going to go up 4. okay? It's going to go up 4, and then minus 3 goes to the right, since it's minus, to the right 3. Are you good on that, Taylor? Are you understanding the whole 4's on the outside? That means a vertical translation. That means I'm going up 4, and negative 3's on the inside, and I'm going right 3. Are you good on that? Give me a response on that. Okay, cool. So then from there, just like I said, do you know, you remember the whole, right 1, up 1, right 2, up 4? So because you understand that, okay, so we've taken care of those two. So I marked those two out, and what am I left with? Just the square root of x. Well, we made this little chart right here. This is our guideline for the square root of x. Same thing, we had the same guideline up here for x squared. Once we found our point, we would go right 1, up 1, right 2, up 4, right 3, up 9. Same thing here with the square root of x. But from wherever that point is, we're going to go right 1 and up 1. We go right 4 and up 2. Right 9 and up 3. And we derive this right here from the original function right here. So from here, just from the square root of x, you go right 1, up 1. Right 4, 1, 2, 3, 4, up 2. Right 9 and up 3. So that gives us this right here. So once we did the up 4 and right 3, then we just follow that pattern to get the square root of x. Right 1, up 1. Right 4, up 2. And then, of course, we go right 9 and up 3 eventually. But that's off the graph. Is that making a little more sense with you? Correct. Yeah, correct. So this is kind of the shortcut opposed to doing the XY table. So it's not going to look the same as like number 1. 3 looks like this, and 1 looks like this. So yeah, you're correct in that. It's not going to look the same as the original because it's been vertically translated and horizontally translated, but the shape is going to look the same. Right 1, up 1, right 2, up, or right 4, up 2. Okay? All right, very good. All right, let's jump over here to number 4. So looking at number 4. All right, now this is a cube root. Pay attention to that. It's a cube root. So x plus 3 minus 3. So the minus 3 is a vertical translation down. So go down 3, 1, 2, 3, and the plus 3 on the inside goes left 3. 1, 2, 3. So there, right there is my point. That's almost kind of like my new origin. Taylor made a good point. It's not going to look the same as what the original looked, but it's going to have the same shape that it has. Okay, so from there, this is a cube root. So we're going to follow our cube root movement, which is right 1, up 1, right 8, up 2, left 1, down 1, right 8, left 8, down 2. We derived this right here, this shortcut formula from the actual function. Now, at any time, guys, you all can know that if you don't know how to graph it, just make an XY table. And you just got to plug values in there. And trust me, that's going to get tough for you to get nice, clean numbers. So that's why I like going down 3, left 3, and then from there just using our points over here. So we go right 1, up 1. Right 8, 1, 2, 3, 4, 5, 6, 7, 8, up 2. Then from that same point, I go left 1 and down 1. And left 8, 1, 2, 3, 4, 5. I really won't have enough room over here. But I know this graph does this right here. Looks like that. Give me a thumbs up if that's making sense to you guys. Good Terry, good Adam. All right. So let's go to the back side. Good Jake, good Andy, good Taylor, good Chris. All right. I left some space there, but we don't got to worry about that space because I just want you to get practice with problems like this, okay? So don't worry about the space up there. All right, so let's just jump to number 5. So here we go, number 5. Plus 1 on the inside, plus 1 on the outside. Plus 1 on the inside means to go up 1. Oh, yeah, good call, Chris. Always do the domain and range. I always need a domain and range person in the group, okay? And here's the beautiful thing about the domain and range of the cube root of x functions. All of them will always be from negative infinity to infinity. Okay? All x values are here. The arrows go forever, and the arrows are always increasing and decreasing forever, so that means their range is any number as well. Okay, thanks, Chris. All right, so then going back to the back side, looking at 5. So the positive 1 means to go up 1. The inside means go left 1. So up 1 and left 1. That takes care of that and that. So now I really just have the cube root of x. So I graph that just like I would on the front side. You just got to get those numbers in your head. So like right 1, up 1. Right 8. 1, 2, 3, 4, 5, 6, 7, 8, and up 2. Left 1 and down 1. Left 1, 2, 3, 4, 5, 6, 7, 8, and down 2. So it should look something like this. Going up that way, going out that way. As I said earlier, my domain, negative infinity to infinity. My range, negative infinity to infinity. All right, looking at number 6. Moving on, if I don't have any questions. Looking at number 6. Y equals the square root of x minus 2 plus 3. So, plus 3 goes up 3, minus 2 goes right 2. So, plus 3, 1, 2, 3, and then go right 2, 1, 2. That's my point. Notice what this is. This is a square root. So, square root. Now, the way I always remember it, guys, is I'm used to doing a ton of parabolas. Right 1, up 1, right 2, up 4. It's just the opposite, right? So go right 1, up 1, But instead of going right 2 and up 4, we go right 4. 1, 2, 3, 4, and up 2. Those are just numbers you're going to have to kind of know off the top of your head, just like you got x squared down. Some of you may not have gotten those down, but pretty simple. Then we just do domain and range from there. My domain, what are my possible x values? So none of these x values are part of the graph, so I go at 2. And 2 is, so I actually need a bracket there, not a parenthesis, 2, comma, to infinity. It goes forever that way. So from here, from right here, all the way out, all those x values work, so we say from 2 to infinity. My range is the possible the y values. Yeah, Karen. I wrote them down here. I don't know if you were quite there yet. These are the numbers you need to know for those. Okay? Right here on the front, the square root of x, right 1 up 1, right 4 up 2, right 9 up 3. And I gave the example up here. Remember, with x squared, we said right 1 up 1, right 2 up 4, right 3 up 9. Okay? So we've done the same thing with all these, so that's these two numbers. Yeah, no worries. Okay, so then range is my possible y values. So none of these y values work until we get to right here. And then you see that line going up forever, and that's infinity. So from 3 to infinity. And 3 is included, so we put a bracket on it. Infinities always have parentheses. Okay? Infinity is not a number. It's not a specific number. It just means goes on forever. Okay? All right. Moving right along. Hopefully you guys are seeing this. Ask me questions if you don't. All right. So jumping down here to number 7. This is a cube root one. So think snake. It's going to be a snake. And if you remember, like with x cubed, it's kind of the same way, but it's just going the other way. Okay? It's just simply going the other way. So we got plus 3. That's up 3. 1, 2, 3. Up 3. 1, 2, 3. And plus 1 is to the left one. So we put a point there. Then from there, I'm just graphing the cube root of x. On the front side are those numbers. It's right 1 up 1, and then right 8 up 2. It's the opposite of this. This is right 1 up 1, right 2 up 8. So it's the opposite. Go right 8. 1, 2, 3, 4, 5, 6, 7, 8, and up 2. Same way here. Go left 1, down 1, and then go left 8. 1, 2, 3, 4, 5, 6, 7, 8. Go off the graph a little bit and down 2. And then I just play connect the dots. All right, so then we just domain and range, and then like I said, with domain and range, it's just from negative infinity to infinity, negative infinity to infinity. All right, last one of the day, guys. Minus 3, minus 4, so that goes left, or excuse me, down 3. 1, 2, 3. That is that. Down 3, and then minus 4 is to the right 4. So it should be put a point right there. And notice what it is. It's a square root. So that's just right 1 up 1, right 4 up 2. Doing something like that. My domain is from 4 to infinity, with 4 included. My range is from 3, right here, this point, right, and going up, from 3 to infinity. Infinity's up here, so the graph goes from here to there. Domain's from here to, and infinity's there, so it goes from there to there. That's domain and range. All right, how we feel about it? Any questions of me? Give me thumbs up if you feel pretty good about it. Good Adam, good Andy, good Chris, good Taylor. Good Karen. All right, hey, just some quick things on your homework. Oh, you're right, Chris. It is -3. Very good. It's -3. Look at you, Chris. You're all over the domain range today. Very good. It's -3, not 3, because it goes from here all the way up. Very good, Chris. All right. Couple things on your homework. There's some that I accidentally put in there. Don't do number 5. Don't do number 6. Okay? Now, just because that, look at number 4, just because that 1's in front of there, guys, that just simply means go up 1. Okay? That's on the outside. Same way with -5. That's on the outside. So you should go down 5 and then graph that. All right? So don't do 5. Don't do 6. I'm on the homework. And don't do 7. So don't do 5, 6, or 7. Everything else you guys can handle. All right? Again, so on homework, do not do number 5, number 6, and number 7. Any questions of me? Make sure, hey, on the homework, make sure you do the domain and range, though. It says identify the domain and range of each and sketch the graph. So make sure you do domain and range, okay, and then sketch the graph. So you need to have domain. If you want to do that like early, and range for each one, you just go ahead and do that if you want, okay? Domain and range for even the ones on the back, too, guys. Okay? Shouldn't be that bad of homework. I don't see any other questions. Give me a thumbs up if you're good, and then you're free to leave, guys. Thanks so much for being here today. Don't forget, tomorrow is Thursday at 5 o'clock. You have the login and password. We'll be right here with some Zoom, just to kind of see each other, talk, maybe ask some questions, see how everything's going, discuss the MJ documentary. I don't know. We can do whatever. So maybe, 5, 10 minutes, could be 15. We could get into an hour discussion. No telling with us. So feel free to come back if you're good. Thanks so much for being here today, guys. Getting you out in under an hour. So that's pretty good timing. So, hey, make sure you get your homework done. I'll see you tomorrow at Zoom, and then I won't see you again in class, lecture, until Monday. Hope you guys have a good one. Be safe. Be smart, guys. I'll be here for just a couple more minutes. If you have questions, type them into the chat box. As always, you can email me.